Hey everyone, this is Andy Malbuff, and in this video we're going to continue our look at using computation layer, this time for teachers to create check responses in the teacher dashboard. Now these are going to be a little bit more advanced than the previous video we looked at, but let's go ahead and dive into this and see what kinds of things we can create. Now what we're looking at here is the student preview of a slide that asks students to move or drag two movable points to create a line with a slope of -3. So right now, if I were to just drag this as a student, I have an X up here in my dashboard check, meaning this is clearly not a slope of -3. Once the student drags one or both points to create a line with a slope of -3, there's a check there. And the student can drag one or both of those ordered pairs as long as the line resulting has a slope of -3. So how do we go ahead and build that? Well, I've got a second slide set up with the same identical components. I've got a graph component on the left, a note component with the directions on the right. And the first thing we want to do is set our graph component to provide for students what we want them to see. Well, we wanted two movable points, so we create those by using generic letters. I'm using A and B here, and when I add sliders for both of those, it creates a movable point. I'm going to label that point, and you can see that the label changes as I move this point. However, I want to have them move in increments of 1. I don't want this to be too sophisticated for the students and have it be too aggravating, so by creating the steps of 1, now every time they move this point, the X and Y increments are in 1. I'm going to follow up with a second movable point. I'll use C and D. I'll add those sliders. I'm going to make the color the same. I'm going to add the label, and also I'm going to make steps of 1, just like I did in the previous one. So now we have two movable points, and now we need to find the slope of the line that would go through those two movable points. In mathematics, we typically use the letter M to indicate slope, and slope is defined as difference in y's over difference in x's. Okay, rise over run, if you will. Well, my y values are D and B, so I'm going to use the difference of D and B and the difference of my x values, which is C and A. So as you can see here, the calculator provides a slope right now of 2, the way the points are aligned. If the student adjusts these points, you can see the slope changes, and as long as they're not right on top of each other, creating a vertical line, there will be a defined slope. Well, I also want a line to go through those two ordered pairs. So to create a line with ordered pairs and a known slope, I want to use point slope form. Y minus, I'll use D in this case. Now you see a line going through these two movable points, and that line follows these points around. So this is something manipulative for the students to look at. But the last thing I want to do is be able to check for myself as a teacher, is M correct in the teacher dashboard? So I can set that M up here in the script. I'm going to use my correct sync, which is teal colored and a colon after it. And I want this number M to be equal to -3. Once I have that set in there, Activity Builder is going to check, is the number M in this component equal to -3? So if we jump into preview mode here, once the student starts manipulating, the dashboard check does not appear because the slope is not -3. And that's close. There we go. There's a slope of -3 there, so the teacher dashboard preview shows a check there. So the next type of situation we're going to look at is, how do we set the dashboard to evaluate whether a student has entered a graph or a function correctly, rather than just moving around points that the teacher creates. So here's something that we want students to do, maybe match a parabola. And if a student types in x squared, student's graph shows up visually, so the student can see that they're not right, but the teacher dashboard shows an X. And so if the student were to type in the correct response, Visually, the student sees the parabola they typed in blue as a correct match, and we get a check up here. So how do we build that in the computation layer from the teacher perspective? Well, we're going to use something called a difference of functions. So I'm going to go into edit mode, and I'm going to go into this same setup here where I have duplicate components set up. And this time I have an input, and I've already identified or labeled it as input number 2. I've got my note component, and I've got a graph component here that I've identified as graph number 3. So the first thing I want to take a look at is, what do we want students to see in the graph component? Well, in this first line, this is what I want to set them up with. I want them to match that. Okay, then I also want them visually to see the results of what they have, what they're entering. So we're going to create a second function, g of x. Now, g of x is not graphable right now by Activity Builder. It doesn't have g being defined yet. We're going to define g in the computation layer based on the student input. And then down here, a couple boxes below, we need to do our check. So what we're going to do is create a list of values. I have a capital X, meaning it's going to be a list of individual values. We use a square bracket on the left. And if I type in -5, comma, ... 5, Decimals Activity Builder recognizes we want the 11 integers between -5 and 5 inclusive. And what we're going to do is we're going to substitute those in to each of the functions, to f of x, g of x, and look at the difference in them. Because if a student types in the correct function, the difference in the two should be 0. So in line 6 here, here's how we set up this difference of functions check. What I've highlighted right here is we're going to subtract the two functions for each input in our list above. And it doesn't matter that I have g of x first and f of x second, because I have them in absolute values. So we're taking the positive difference in those two. Now, ideally, we want that difference to be 0. If they sit right on top of one another, the difference in those outputs is going to be 0. So the rest of this here basically is saying, I want to take the total of those differences, and if it's equal to 0, which would be a correct response, then we're going to let the value of c be 1. Notice here there's a colon, okay? And what that means is c is going to be a value of 1 if the stuff to the left of the colon is true. If the stuff to the right of the colon is not true, c takes on a value of 0. So c is going to be either 1 or 0. 1 meaning correct, 0 meaning incorrect. And then let's jump into the script here for the computation layer. I need to define g here. So we're going to use the function sync, and I want to label it as g. We're going to define g right here, and we define it as a simple function that takes input number 2, the LaTeX, as its source. And so what's going to happen is whatever the student inputs for input 2, Activity Builder is going to recognize it as a simple function, and it's going to assign it the function definition of g of x. But I also don't want Activity Builder to check this graph for correctness, because we're going to check for correctness in the input. So we're going to tell it to read only true, meaning that Activity Builder won't grade this graph for correctness. Instead, we're going to put the correctness down here in input number 2. Now, first of all, just a little bit here, I want to prompt my students with function notation, so that's how I indicate that with initial LaTeX. And then I'm going to use my correct sync. So I want my correct sync to pull the number c from graph number 3. So I'm going to use graph 3, the number c, and I want it to be 1 to display correct responses. Okay, so let's take a look at this in preview mode. If the student types in x squared, visually the student sees they're wrong. In the teacher dashboard, there's an X that appears. So if the student enters the right response, the check mark appears here. And the format that the student uses doesn't necessarily have to match what I just typed in, as long as the functions, the difference of functions, is 0. So they could use, instead of that vertex form, they could use standard form, and the same response will occur up here. The third scenario we're going to visit here is quite a bit more sophisticated in my opinion. It's got a graph correct check, but it's also got 2 separate checks in it, and it's got some pretty cool bells and whistles. Give credit to Ryan De La Garza. I got the idea from him watching one of his YouTube videos that we can provide individual checks for students, and you'll see this in just a moment. So we're asking students to put in a function here that's going to go through those 2 points. So to make it simple, we'll use a linear function, and if a student just simply types in x, notice nothing's graphed yet until they press submit. And then here's some visual feedback for students. Now clearly that line does not intersect those 2 points. So we're asking students to make some adjustments. If they type in the correct function and press submit, visually the students will see their points go through, and they get some nice visual feedback here. Check marks appear as these points fill in when the line goes through them. In the dashboard, we get this check as well. So how do we go ahead and build this type of thing? So I'm going to exit here, and I've got 3 components: a graph component, a note component, and an input component. And I'm just going to basically show you how this is set up, because it involves quite a bit more time here. And so the users of this, you're welcome to do what you'd like with it. First of all, f of x here. This is not graphed by Desmos right away because it's not defined. This is similar to what we saw on the previous screen with g of x. Instead of adding sliders, we're going to define function f in the computation layer. We're also going to define t in the computation layer. T is going to be a timer. Basically, it's going to allow, in real time, the graph to display once the student presses submit. Okay, the timer acts as a starting switch to graph this line. So that's how we get the function to show up there. We'll be back to that in a moment. My 2 points here are entered using a table, and in the first column, those are my x coordinates, and in the second column, those are my y coordinates, or output values. So the desired function here is going to be 2x plus 2. So the 2 ordered pairs that I'm showing are -3, -4, that's the one on the left, and 1, 4, that's the one on the right. And ideally, we're going to get students to have a function that goes through both of those. Here's where the new part comes in, our correct checks. We're going to have 2 separate ones. We're going to have a first correct check, C sub 1. In other words, is the student's function going to go through that first ordered pair? Well, the first ordered pair is at -3, -4. So we're going to have some conditions here. The first correct check says if the student's function goes through -3, -4, we're going to assign it a value of 1. If it doesn't go through -3, -4, it assigns C sub 1 a value of 0. So that's our first correct check involving just this point right here. We have a second correct check right below it that's very similar, except now we want the student's function, f of x, to go through the ordered pair 1, 4. If that occurs, C sub 2 is assigned a value of 1. If that does not occur, C sub 2 is assigned a value of 0. And since we have 2 of these and we want to judge in our dashboard, did the students get both of them right? Well, we're going to use this right here. Notice that's a capital C. And the overall correctness of this graph, if you will, is going to be based on multiplying those 2 individual correct checks together. If they are both right, if they're both 1, C sub 1 times C sub 2 will be 1. And that will be what we look at in our individual input component. Now, here are some fancier bells and whistles that Ryan did that I thought were pretty cool, so I'm going to include them here. Did you notice that when the student's line appeared near this point, if it went through it, the point filled in? That's because of this point right here. So This point will display as a filled-in point with two restrictions on it, or two domain conditions on it. The first one is the first correct check true? Is the first correct check equal to 1? And once my timer value allows the function to get to -3 or greater, that's the x coordinate there of that first point, then this point will display. Now, I'm going to quick add the sliders for this, just so that you could see the label I've created is the check mark here. It's just an emoji I copied in there. The second point also will display with similar conditions. If the second correct check is true, and once the function's value based on the timer reaches +1 or greater, it will be filled in. And that's the x coordinate of this second point. And lastly, well, not lastly, but I need to check my computation layer script here. So we're going to define function f, similar to what we did with function g in the previous page, except now it's just the component is input rather than input 2. And we're going to define a timer also. We're going to define that number t as based on the input from that component with the source of time sent submit. What that means is once the student presses submit, T will be activated and start counting from 0 up to 10. It's a 10-second timer, and that will allow us to graph the function in real time. And as we saw earlier too, we're not going to grade this graph for correctness, so I put read-only true in there. And here's our input component, and here's our correct check. From our graph component, I want to see that the number C is equal to 1. This is similar to what we did before. So, showing you in preview mode one more time here, a correct response. As soon as the student types in the 2 there, they don't see this yet, but the teacher sees the check. So both of the individual correct checks have been satisfied. But when they press submit, the timer is activated. And then they get that visual feedback, a label of a check mark at each point. And the last correct check scenario we're going to look at is parsing. Parsing basically means separating. So oftentimes in middle school and high school math, students have to do some work with ordered pairs, and we need to evaluate, is the X part correct, is the Y part correct, etc. So here's a simple system of linear equations, and the students are asked to write an ordered pair that represents the intersection. So if they were to type in the ordered pair 3, 4, the teacher dashboard shows an X. It's incorrect. If the student types in the correct response of 6, 12, oh my God, got fingers. There we go. The correct check shows up on the dashboard, and this is judged to be correct when the teacher's looking at the entire class event. So how do we go ahead and build that? Well, I'm going to exit out here, and we're going to jump into a similar scenario and build this. Now, what we have to do is I'm going to go into the input here, and we're going to have to create a variable that will separate the student's input into 2 parts. So I'm just going to call that variable solution. And I want it to parse an ordered pair. So after the equal sign, I type a P in there. I want to parse the ordered pair from the input. Now I forgot how I named it. This is input 5. I'll go back there. I want to use input 5, the LaTeX. What this is going to do is it's going to say input number 5, we're going to separate the ordered pair. We're going to parse it. We're going to keep it separate. And then our correct check involves this. We're going to use our correct sync. And what I want to do is look at the numeric value of solution. And I'm going to choose the X part. What it's doing is we're looking at the numeric value of the X part of the variable solution, which we got by parsing. And I want that to be equal to 6. But because this contains a second part I have to compare, I'm going to connect these with and I'm going to do a similar type of thing. Numeric value, solution, and this time I want the y part of the solution, and I want to know that that's equal to 12. So with this set in preview mode, if the student types in 6 comma 10, we get an X here. Even though the 6 was correct, both of them have to be correct. So if the student were to enter 6 comma 12, the icon here changes to a check mark, and the student is indicated as being correct on that. Okay, thanks everybody.